This is a review of Hess's law. Hess's law are problems where you solve the enthalpy of a net reaction using steps. Oftentimes, to solve these problems, you have 2 or sometimes 3 steps. And what you're going to do, in this case, we have 2. And what you want to do is you want to identify, you want to use the steps and rearrange them and make them look like the net reaction. So there are a couple ways to solve the problems. What I recommend is that you find, in the first step, you find a reactant or product that is unique to the step and it is in the net reaction. So I didn't pick phosphorus or chlorine because they're in both reactions. Instead, I picked PCl3. PCl3 is not in the second step, and PCl3 is in our net reaction. Once we've identified something that's unique, you want to ask yourself 2 questions. First, are they on the same side? And second, do we have the same number of them? So what I can see here is that in this first step, PCl3 is a product in the step, but it's a reactant in our net reaction. So what I need to do is I need to flip this first step so that they're on the same side. The second thing I need to do is look to see if we have the same number. I have 2 here, and you do this by looking at the coefficient, and I only have 1 here. So I also need to divide this whole reaction by 2. So when I rewrite this, my products become my reactants because I flipped it. And also, I divide all of the coefficients by 2. So I get PCl3, I get phosphorus, and then I get 3/2 chlorine. Also, because we flipped it, our sign of our enthalpy becomes positive since it was negative before. And we divide by 2, so we get 320. I'm going to do the same thing with the second step. So in the second step, again, because phosphorus and chlorine are in both reactions, I don't want to use them. PCl5 is in our net reaction and it's unique. So I'm going to ask myself the same 2 questions. Do we have the same number of them? And are they on the same side? So I can see that they're both products. They're on the same side. However, we have 2 PCl5s in our step and only 1 in our net reaction. So what I need to do to this is divide by 2. So I'll rewrite the equation, keeping everything on the same sides but dividing by 2. So I get P plus 5/2 Cl2 goes to PCl5. And the only thing I need to do to my enthalpy is divide by 2. So I'm going to take negative 886 and divide by 2. It stays negative, and it becomes 443. Now our answer will be the sum of these 2 values. And what we can do to check to see if we set these problems up right is that when we add up our 2 reactions, everything should cancel out except for what is in our net reaction. So we can see, because we have a phosphorus in the reactants and in the products, they cancel. We have 5/2 Cl2 in our reactants and 3/2 Cl2 in our products. Because of that, we have 1 more Cl2 and these 3/2 cancel out. So what we're left with, so this would, when we subtract 3 from that, that becomes 2/2, which just becomes 1. We're left with PCl3 plus Cl2 goes to PCl5. So again, our answer is just the sum of these, which is negative 123 kilojoules. Now this next problem is a tougher one, and I picked this on purpose to go over it with you. And what we're going to do with our 3 steps here is identify a reactant or product that is unique in each of them. And for the first one, it's easy. We have calcium in the first step, but not in any of the other steps. I didn't pick carbon because carbon's in our second step. Now in the second reaction, There's nothing that's unique. Carbon dioxide is in our third reaction. Oxygen is also in our third reaction. So I'm going to wait and figure out what to do with that once I decide what I need to do with our first step. For the third step, I can identify calcium carbonate as the unique thing. So what I'm going to do now is I'm going to rewrite the first step and the third step and then figure out what I need to do with the second step. What I can see is that calcium in here in the first step is a reactant, and it's a reactant in our net reaction. We have the same number, so I'm just going to rewrite this equation, the first step here, just to make it look like I have. And then our enthalpy also stays the same. For the third step, I can see that I have calcium carbonate as a reactant, and it needs to be a product. So I need to flip this reaction, but I don't need to multiply it because they have the same coefficient. So when I rewrite it, I'm going to flip the reactants and products. So calcium carbonate becomes a product, and then when I flip it, our sign changes. Now for the second step, what I need to do is figure out like what needs to be canceled, and what I can see is that carbon dioxide is not in our net reaction. So I'm going to use carbon dioxide in the second step to figure out what I need to do. I'm going to look to the third step that we rewrote down here and see how can I cancel out carbon dioxide. So what I see is that since we flipped that third reaction and carbon dioxide is a product, I want to keep the reaction the same so that carbon dioxide cancels out. When I add these all up, our calcium carbide cancels. One of our carbons cancel because we had one in the product and one in the reactant. Our carbon dioxides cancel. And this is like 2/2 oxygen and 3/2 oxygen. So what we're left with is calcium, carbon, 3/2, which is the same as 1.5, and calcium carbonate. And then all I'd have to do is add up these values here to figure out the enthalpy of the reaction. So if there's a problem where you don't have anything unique in it, look to your other steps to figure out what you need to do to cancel out a reactant or product.